Hi, Hawaiian Shirt Coder here again, and welcome back to part 9 of our Web API series. In this episode, we're going to have a look at wiring up our data access layer. So let's have a closer look on what we're going to talk about in this video. So as the title implies, we're going to hook up our data access layer. So if we have a look at our current design, you can see we have a lot of stuff in place now. We now have our web API. We've got our in-memory database that in this video we're going to start to get rid of. We've got a SQL database, our final persistence piece of infrastructure, and we've also in the last video actually implemented a data access layer that will allow us to talk to our SQL database. So what we need to do now is decide where we call our data access layer. So where will the calling code be that will make calls to the data access layer, which will in turn make calls to the SQL database. So I'm going to show you two approaches, and this video is concerned with approach 1, where we're going to call our data access layer directly in our controllers. So here's the learning outcomes from this video. What we're going to do is we're going to call our data access layer, or DAL, from within our fixtures controller. And to do that, we're going to have some other steps. We're going to show you how to get your connection string out of the hard-coded state like we did in our test harness and stick it in app settings. We're going to inject the data access into the fixtures controller rather than this new as glue problem that I discussed while we were hooking up our test harness, and we're going to do that via dependency injection. With regards to dependency injection, we're going to wire up the system so it works. We're not going to go into great details about how dependency injection works, so it won't be a deep dive on that. That may take place in a future video, as it's quite a complicated subject area in its own right. And we're also going to start using asynchronous calls to handle database interactions. At the moment, all our controller endpoints are synchronous, and we'll go into why that's important as well. So in part 8 of our Web API series, I created a data access layer. Its responsibility to issue SQL queries and commands at the SQL database. At this stage we haven't hooked that up or haven't made calls to that DAL, but it is now in place. Before I go on in this video, I'd just like to point you to a couple of refactors I've done since part 8 to do with the method signatures in our data access layer, or the data access. So if I double click on this, so I'm in Git changes, on the left hand side you can see the method signatures that we created during part 8 of the series, and on the right you can see what I've changed it to. Let me just walk you through these. So on the left hand side, when you run a query, you pass in a SQL statement the parameters that are required, and you provide an optional command type, which can be text or a stored procedure, and you also provide a connection string. This one is slightly misleading because you don't supply a connection string. What you actually supply is the name of the connection string, which I've called SMS, so it'll go and try and look up SMS in the background and pass that through. On the right hand side, what I've done is I've changed this. I've decided I'm going to do away with this optional connection string and make it that the caller must supply a connection string, and that will be the actual full-blown connection string, just for simplicity. And then I've put the command type, which is still an optional field, but I put it at the end. And if you don't supply a command type, it will automatically set the command type in the background to text. I've done exactly the same on the executor command. So we are always going to supply a connection string now, it's not an optional field, and we've changed the ordering. So the ordering is now SQL statement, parameters, connection string, and the optional parameter of command type. So based on that, when I recompiled the project, broke some things. So one, it was saying we weren't implementing the interface, which is data access, so I had to go away and adjust the method signatures in the interface by swapping the connection string round, taking off that it was optional, and putting the command type at the bottom. The other thing I had to do is in our test bed, I also had to go and change the method signatures in that, as they were the wrong way round. So just to show that, is in this example on the left, it's been changed, and this is the key bit, lines 21 through to 24 have now been changed to this. So now we supply the SQL statement, any parameters, and the connection string, rather than the SQL statement, any parameters, the command type, and the connection string. And if, like I said before, because command type is now the last parameter and is an optional parameter, if you don't supply it, it will assume it is text. After doing all of that, the project then built successfully again. And just to prove it, we'll go back to our test the DAO, and we'll just open up program.cs. And we've got example 1, which will give us a list of players based on the new signature, like I said there. And the connection string getting passed in is this variable with the actual long connection string in rather than the abbreviation. And if I run that up, we should still get results, which we do. So just thought I'd point you in the direction of that refactor. You can pick up the change in the GitHub repository, and now we can move on to some more interesting bits. So if you look back in our test the DAO example, we have this connection string that we've hard coded into our program, and as I've stated in the comment, we don't really want to do this because hard coding is never a good idea, because as soon as you change the environment, the connection string is incorrect and involves you having to recompile all your code. So configuration should live in configuration settings. So that's what we're going to do now. Again, configuration and configuration settings is a large topic, and I'm just going to show you the standard configuration settings and maybe save configuration settings as a full series at a later date, but for now they're going to go in something known as the app settings.json file. So let me just show you that. So first of all, I'm going to undo any previous changes, as that may show everything, and I want to walk through the change with you. So in your sms.api, there should be a file called app settings. This is where we can hold any configuration that may change from environment to environment, and this is a perfect place for us to place this connection string and then be able to read it in. So what we're going to do is we're going to add our connection string into app settings.json. So this is what app settings.json looks like out of the box, and we need to add a new entry in here. So let me just paste that in as I've got it on my other screen. and walk you through it. So after this last entry here, we're going to put a comma, hit return, and then we're going to put in a brand new heading called connection string. And within the connection strings, there could be several connection strings. So it's put in an array. And actually that's not an array, it's an object, JavaScript object. Within that JavaScript object, we can have several connection strings. So the connection strings go in the following format. They need to have a key, which is SMS in our case, could be called anything, default, database, thread, whatever you want to call it, colon, and then the actual value. So this is a key value pair, and the value is the connection string that we'd hard coded in our mock-up console application. So I've pasted all that in there. That looks exactly the same. So that's now available to access at a later date, which we'll come to in a bit. So that's the first stage with integrating our solution. Whichever approach of the two approaches I'm going to show you, you're always going to need to put your connection string in your app settings file. So following along after putting our connection string into app settings, we're going to use the test bed that we had earlier as our sort of step-by-step guide. So basically we've handled line 7. This is now moved into our app settings for our web API. The next bit is to be able to call our data access layer. So again, there's a comment here that says new is glue. So we're not going to write this code into our controllers or wherever else we're going to place our data access code, as this is bad practice, and we end up in this coupling situation again, and things become difficult to test, and so on and so on. So new is glue. So what we need to do is we need to find a different approach to be able to instantiate one of these objects. And I'm not going to go into a great deal about this in this video, because I think I'm going to have a separate video all to do with something known as DI, or dependency injection. But I'm going to show you the mechanics in our web API of how you set up our data access layer. So what we need to do is we need to we can close this one. We need to go back to our web API. Here's our web API, and we need to go into program.cs. As I said in earlier videos, program.cs is the entry point, the sort of bootstrapper into our web API. It's where everything gets configured up. All the services that are required to run the web API get set up. It is our middleware, our pipeline stuff that needs to happen before you see any of the Swagger screens, or you can do any interaction with the web API. So we haven't really been in here a great deal. The only time we've really come into here and added something ourselves is this section here, where we've got our venue enums, and we actually want to display the words home and away out to screen rather than their values, which was 1 and 2. That's the only change we've made. All this other stuff was put in for us when we went file new web API project. But you'll see when you're going through here that one of the things that you can do is you can configure services that your application needs. So for example, it's got builder.services.add swagger gen, and what this is doing is it enables us to have our Swagger tryout UI pages that we've been popping up. So in essence, our custom services that we've been making, and so far we've only made one, which is a data access layer, is a service that we need to plug into our web API. So that's what we're going to do here, and like I said, I'll go into more details of what it all means in terms of dependency injection in a later video, but for now we just need to wire it up and the explanations can come later. So on a new line, what we will put is builder dot services dot add scoped angled bracket, and the first thing you need to do is say what interface are we trying to hook up. We're trying to hook up an iData access, which is this one. And we have to bring in a using statement, so this is coming from our shared class library using sms.shared.dal, and then comma, and then we say which concrete implementation of iData access we want to use. Well, that's quite easy for us at the moment, as we've only got one implementation of iData access, and that is Dapper data access. And that is it. So what this is basically saying is whenever anywhere in our code there is a request made for something that uses the interface iData access, please instead create me a Dapper data access concrete implementation. So you can see this is broke away from having new as glue, because this handles it all up front. This can even end up in configuration if we wanted it to, so we wouldn't have to recompile our code, and all we would do is swap out our iData access for a different implementation if we wanted to. So for example, if we were using entity framework data access, we'd created an implementation of that. As long as it follows the same contract as iData access, we could swap Dapper out for entity framework and everything would carry on working. So that's the next stage in the process of integrating our data access layer into our web API. The next question is, where do we actually call our methods that reside in our data access area in our web API? Where do we call them? So this is the first approach that you could use, and then at a later date I'm going to show you a second approach, and the second approach is my preferred approach, and when we get to that one I'll explain why. But the obvious place where you can call this code is in the controller, because that's what we're sort of doing at the moment anyway, even though it's an in-memory database, is we are saying go and get the data in the controller. So for this first approach, adding the data access layer to the controller calls, I will use the fixtures controller to show how you do this. So if we open up the fixtures controller, and what I'm going to do is I'm not going to change every single one of these methods, because like I said, this isn't my preferred method of doing it, but it is a method that will work and is fine, and certainly is fine when you don't have much business logic that sits between you requesting the data and getting the data back. If you are getting the data back, then doing further processing on it, this is not the best approach to use. But I'm going to show you both approaches, and based on your use case you can pick which one suits you best. So the method I'm going to change is this one, get all the fixtures out of the system, and at the moment this is using our in-memory database to go off and get all the fixtures that are in the hard-coded list. We'll just fire this up just so we're familiar with it. Set as start project, run this up, we go. So under fixtures, we've got this endpoint, and we're just going to try it out, and all of the results come from memory. There we go. They're all out of memory, so that's good. So what we're going to do is we're going to comment this out, and we're going to actually implement it that it is using our actual database through our DAL. So first things first, if we go back to our test bed that we used, you will notice whenever we call any of the data access methods, so here's an example of one on line 20, and another one, say let's go down the page a little bit, on line 55, they all have something in common. They are all using the word await. And await means that this method is asynchronous. So if we go to our data access implementation for Dapper, you can see it says public async, which is asynchronous, task. So what is this asynchronous stuff all about? Well, we want to use asynchronous tasks when we've got something that can be quite an expensive call. So now we've introduced some actual physical infrastructure into our system, a database. There is going to be a degree of latency to go and make a request to that database for it to do its stuff and return the query back to the calling code, in our case the web API. Whereas when we were using an in-memory database, there would be little to no latency because it's not a third-party resource, it's actually baked in and it is part of the application. It's just in a memory allocation, all to do with our web API, so there is no latency. So we can make those calls synchronously because they're not really going to take any time. But as soon as we introduce a third-party resource, such as a database, we are saying, go and do something to this third-party resource. That third-party resource may take a long time to do it. And while it's taking a long time to do it, it's going to tie up a thread. Our end and may block or freeze our UI if we use synchronous calls, which is what we're currently doing at the moment. So a good example of this is you make a call to the database and you somehow unintentionally you have written a really inefficient SQL query that when it gets fired against the database takes a long time to run, say 20 seconds, and for those 20 seconds all you're seeing on your UI or in your request is it's waiting and it's waiting and it's waiting for a response to come back, and until something comes back you can't continue on. Whereas what we want to do with potentially long running tasks, which database connection and a query is make that asynchronously. So fire it off to the third party resource and not tie up any of our front end or UI. So how we do that is we use asynchronous. Now the thing with, as soon as you use asynchronous, it needs to be used everywhere. So by everywhere for our web API, we need to make an adjustment to our call. So at the moment, this call is a synchronous call. So it's using all the same thread. It will wait until we get a result back from the third party, which is the database. So what we need to do first of all is just swap this out to async to make it asynchronous, and all asynchronous tasks deal with something called a task. So we also have to put the word task, and then the task will return an action result. So that's the first thing we need to do. So all of a sudden, because our data access layer is all written asynchronously, anything that calls it also needs to be asynchronous. So we've made our method call async task of action result. So that's good. Now we need to hook up our fixture controller to actually use our data access. So let's do that next. So the first thing that we need to do is create a constructor for our fixture controller. So let's do this. And you can do this with the snippet CTOR, then press tab twice, and that will create a constructor. And this constructor will be injected with a couple of things that it needs. So the first thing that it will need is it will need to know about our data access. So what we do is we don't pass in a Dapper data access object, because as soon as we do that, it is hard coding this controller to use Dapper. What we do is we always pass in an interface. So we say data access, and then we'll call this data access. So that's good. And the other thing that we need to pass in so we can get access to the app settings and be able to extract our connection string is we need to have access to something known as iConfiguration, which again is an interface, but it deals with how you get at configuration settings. Now, if you've been beady-eyed, you will notice this exists in our program CS file. Wrong program CS. This one, because you saw me add it in the previous step. So you would assume that iConfiguration would also be added as a service, and it is. It's just you can't see it because it is a thing that comes out of the box as part of the web application create builder. So it's already been wired up in the background, so it's not one that we have to specify ourselves, but in the background it has been set up exactly like this. So it will say when you see an iConfiguration, please use and whatever version of configuration concrete implementation comes out of the box, which again means we can swap it out if we want to, but there's no need to swap it out as the default configuration is fine for what we need. So we've got our iData access. We also need an iConfiguration that I'm going to call config. Then what we need to do here is we need to right click quick refactors and create and assign data access field, and then we need to do the same for this one as well. And what we're going to do is I've got a naming convention as I don't like how it gives us this. So I'm going to change these. So all my fields always have this underscore data access and underscore data config, and then we're just going to swap these out to that. So what this is doing in the background is it's saying when we spin up a new fixture controller, we need to inject in these dependencies into our system. We need to tell the fixture controller it needs a data access interface and also a configuration interface. And how it does that is when the machine first boots up the web API, the very first thing that gets fired up is the program CS, where everything gets wired up that the application needs. So it'll say when anyone requests an iData access, give them back a Dapper data access. And like I said, the configuration one is also there, but it's baked in as part of the template. So it's set both of those up. So this has done away with the need for going data access equals new Dapper data access. which is great because that means we can easily configure that both in the program CS file, or if we could have all those settings in our app setting file if we wanted as well. We need to do one final thing in our constructor method, and for that I'm going to add another private field, private read only, and this is a string this time, and I'm going to call this connection string, and we'll set that to string.empty. And what we're going to do here is we're going to say using the config, we're going to go off and request the configuration connection string setting, and we do that with this line of code. So we'll say that our string variable connection string equals underscore config, so the config service, and if we go dot, it's got a method we could call in there called get connection string, and all connection string needs is the key for the connection string you are looking for, which if we go back to app settings, the key is the first part. This is the key and this is the value. So we just do that. Now this is grumbling or giving us a warning saying that this could possibly be null. We can handle that, but just for now, to get rid of that, I'm going to say it won't be null, and that's what this exclamation mark will do. So we've set up all our fixture controller with the dependencies it needs and the connection string that needs to get passed in to both our execute query and execute commands, and we can reuse that throughout our code. So now we're in a position to actually call our database. So this was the method we were going to update. We've commented out the in-memory version, and now we're going to talk to the database. So the first line we need is a variable var SQL statement, and this is the SQL statement, the select statement that we're going to issue to the database through Dapper. So we're going to say equals, and that will be select everything from fixtures, and that's fine. And then what we need to do then is we actually need to make a call to the data access layer. So I'm going to say var query equals underscore data access, and as soon as you hit dot, it will show you all the methods that this data access service provides us. And we've got our execute command, which is for our insert, updates and deletes, and we've got our run query, which will handle any select statements that we need. So this is the one we need, so we pick this, and then it expects two parameters. It expects the type that will be returned from this query, which in this case is a fixture, and it also requires a dynamic, because a dynamic will allow us to pass any parameters in should this query need them. In this particular instance, it doesn't need any parameters, so we will just provide an empty object. Then we open up our bracket and we fill in the arguments that it requires. So the first argument, looking down in the list, is it needs a SQL statement. Then it needs the parameters. So like I said, this particular one has no parameters, so we'll just supply it new with curly braces. And then it needs the connection string, and the connection string we've got in our private field variable. And if we wanted to, we could also specify the command type, but as this is an optional field, it will default the command type to text. So that's all we need to do there. and we do that. So the next thing that we need to do is, like I said, this is, when we have a look at this, you can see that this is an async method. It's got a waitable. So as soon as you see a waitable in front of something, it needs the word await put in front of it. So in essence, this is exactly the same as what we did when we were using our little console test harness. We've just made the exact same call. In our example here, we were using players, but we've just done the same thing with fixtures. So based on this one above, we've got a little bit more work to do, because we can see that the controller then does a projection to turn the list of fixtures into a list of fixture summary DTOs. So that is the bit we need to do next. So on a new line, we'll go var fixture summary, and we'll say, we'll write a link statement very similar to the one above, from F, let's say from Q in query. So this is our list of fixtures, which if we just put the mouse over that, you can see it's an I enumerable of fixture. And then we'll say select new, and the thing we want it to return is a fixture summary DTO. So we're mapping this from a fixture to a DTO object. So that becomes fixture summary DTO, open and close curly brace, and then we will, rather than type this in, I've got it over in the clipboard, we will map the properties that we need. So let's just pop these in here. So we're going to map the ID against the fixture ID, the opponent against the fixture opponent, and so on and so on. The one that's slightly different is the venue, because in our DTO a venue is a string, but coming from our fixture, let's just go back one, a venue is an enumerator, so we convert it to a string. That's the only bit we're doing different. But that's just another example of how with the DTO we can change the shape. And then finally we have to wrap this in a bracket and then go to list. So that's the query done, and then all we have to do is return back the fixture summary. And that is our method written, so it no longer uses the in-memory database, now uses the database. So I'm going to put a breakpoint on this, and we can step through just to check it's working. So I'm going to fire up the application and go to our Swagger tryout area. So in fixtures, we'll say try out, we go execute, and you can see we've hit our endpoint, get all fixtures, and we can step the code. So we build up our SQL statement, we fire the run a query statement. If I press F11 on this, we can step into this, and all of a sudden we're in our Dapper data access. So it knows through the dependency injection that an iData access will actually use a Dapper data access in this setup. And we come in, and the first thing it will do is it will pass in the connection string that we passed in as a parameter here and set that up, and then it will go away and run this SQL statement with these parameters, in this case no parameters, of this type, which is text, a SQL statement, against the database. And if we scroll back down, invalid object fixtures. So this is good because this has shown that it's gone wrong, and it's gone wrong because I've done a typo. So let's just stop this and rerun it. And as you can see, we get a 500 error back, which is good. And we get an actual full-blown error message, which we would probably hide from the user, which we'll come to that in later videos. But let's go back and fix this and then retry it. So back in the fixture controller, what I've done is I've called it fixtures. Now if you go to the SQL panel, I'm pretty sure it's called fixture. So databases, SMS, tables, it's called fixture. So it couldn't find the underlying table that we were trying to issue a query against. So if I just correct this, take the S off, run it up again, and hopefully this time it's fixed. We go into Swagger, open up the get all fixtures, try out, execute, hit the breakpoint again, press F11 to jump into the Dapper data access code. Again, we've got our SQL statement that says fixture this time. We've got no parameters. We've got our connection string. We run the query using Dapper against the SQL Express database. And this time we get the query back. So the query is of type fixture, which is good. And then what we do is we do a projection on that query to turn it into a fixture summary DTO, which looks like this, which looks virtually the same shape but is slightly different. Venue being a string, whereas in here venue is not a string. Venue, even though it shows as a string, is actually an enumerator. And then we just return OK with the fixture summary back to the user. So F5, and there's our results. So let's just tweak the database just to prove that it's definitely coming from the database. So if we go into the fixture, let's go view data, and let's change Southampton to Saints and update the database. If I go back to the query again and we re-execute this, let's just have F5 this time, scroll down, and opponents is now turned to Saints rather than Southampton. So that's all good. We've hooked up our first web API to use the real database. This would be much the same for the other operations. So for the post and for the deletes and put, I think what we might do is we might just show one of those just to show there's no magic happening in the background. So let's just go down to a nice quick simple one. Let's go to the delete. So at the moment this is how we are deleting our fixture using the in-memory database. Now we're going to swap this out to the real database. So I'm going to comment this code out, as this will be useful to guide me on what I need to change. And then what I'm going to do is I'm going to first of all write another SQL statement. This time this is a delete from fixture where the ID, I think it's called ID. Let's just go check. Yeah, it's called ID, so that's fine. Equals, and this one requires a parameter, so we say at ID. And then we make a call to our data access layer. So we go underscore data access. And this time this is a command rather than a query, so it's not going to return anything back. So we are going to use the execute a command, and we are going to pass in the SQL statement. We're going to pass in, this one does have a parameter, So we're going to pass in a new ID, which is what comes in from the call. And then we're going to pass in the connection string, which is a private field, so it needs the underscore. There we go. So that's done, but again, if you have a look at this, this has the word awaitable in front of it, so based on that we need to put a wait in front of this, and it's still grumbling, and it's grumbling because the thing calling it is still synchronous, whereas this method is asynchronous. One thing we could do if we wanted to make this call synchronous to match this is we could do this, but I don't like this at all, so please don't do this. Run synchronously or result. If it's asynchronous, please call it as asynchronous. So up here we need to go async, and then we need to go task, and it's still a task. It's still going to return an action result, which will allow us to get our nice HTTP status codes of 200 or 404 or whatever, and there we go. For this one we don't need to do a not found because we're not actually looking into the database for it. We're just going to issue this command and it will either succeed or fail. So it's more likely to probably be wrapped in a try catch statement. So let's do that for now. So let's just lift the await statement, place this in here, and if this all works we're going to do a return, and this one's doing a no content, so we'll do a no content, and otherwise if something went wrong what we would do is log what went wrong internally, which we'll do a whole video on logging, but for the time being we will return just to simulate the one above, even though this wouldn't be what I would do ideally, is we would return a not found. Whereas really what will happen here if we hit the exception is something's gone wrong rather than it's not found. So it's not really a 400 error, it would be a 500 error really, but just to keep it so it's doing the same functionally as what this one was doing, that's what we will do. So let's just put a breakpoint on this and run it just to see if it works. And what we'll do is we'll delete Southampton or the Saints, which is fixture 1, I think. Let's just check. There you go, it's retained Saints, whereas when we were using in memory before, as soon as we stopped the application, it would just reset that to Southampton. Now it's persisting it in the back-end database. So we're going to delete that one. So let's just go back into here. Let's close up the get and use the delete. So Southampton or Saints is 1. So we pick 1. We hit execute, hit our breakpoint, and we hit our endpoint, passing in 1, F10, come into the try, F11 to actually go into the method. The method is expecting these parameters, so we've got our delete statement with a parameter passed in. The parameter is 1, so that's good. Here's the connection string, and again we haven't supplied a command type, so it will just use the default of text. F10 sets up the connection using the connection string we passed in, and then executes the delete statement against the database. And we get a 404 not found. So something broke there. Let's just see if we can find out what that was. Let's go back to our fixture and we will put an EX on there so we can have a look at the exception. Let's just try it again. So delete the fixture, so that's good. So we can go back into here, we pick one, we go execute, we step the code, we get an exception. The delete statement conflicted with the reference constraint of availability. So this makes perfect sense because now we've hooked up availability, we have a foreign key issue. So what our delete would need to do is be a bit more clever than actually deleting from fixture. It would also need to cascade delete anything that depends on fixture, which in this case is availability. So we have some availability for the fixture of Southampton. So that's all good. So that's not actually wrong. It's just got the wrong statement at the moment. So that's fine. What we'll do to overcome this is we'll pick one that has no availability just to check that this method is working. So let's go and have a look at our SQL database. And if we have a look in the availability table, we can see what the issue is. We can see that for fixture 1, which is Southampton, we have these 3 records. So in order to delete the fixture, we also would need to delete these 3 records, which we can handle later. But what we haven't got is nothing. We don't have any availability, I think, for fixture 4. If we have got fixture 4 in the system, let's just have a look at fixture 4. So this is one we should be able to delete without any issues. So fixture 4 is West Ham. So no one has put any availability for this. So our SQL statement that is just a simple delete at this stage should work for fixture 4. Let's just try this out. So delete fixture, try out. Let's try 4. We hit our endpoint and this time we're passing in 4. We run the query. We come in here. This time we don't hit the exception. So it thinks it's deleted the record and we go F5. And this time when we scroll down we get a 204, no content, but anything with a 2 means success. So that's good. Just as a final belt and braces, we'll go have a look in the database and West Ham should have disappeared. There we go. So it has disappeared. So yeah, so that was quite a good error to pop up there because that's highlighted a further bit of work we need to do to make our system more robust. Is now we've got availability involved, we've got a table that relies on fixture, and we'll get the same problem when we're trying to delete a player when a player has signed up to some availability. So our queries need to be tweaked a bit so they do what's known as a cascade delete, but we can look at that as we progress further through the series. So we're done. Another pretty full-on video, this one, but we've got some good stuff done there. So that was showing you how to hook up the data access layer using approach 1. We can now delete the in-memory database. This approach 1, is particularly good if your web API is purely a CRUD web API. It basically lets you create, read, update and delete data without much pre or post processing or business logic. In the next video we will discuss approach 2. Approach 2 is my preferred approach and you'll see why, because it allows for future extendability to our web API. So keep watching. So I'm the Hawaiian shirt coder. That's the end of this session. Please remember to like, subscribe, share with your friends. Remember, keep learning, keep exploring, keep developing, and I'll see you next time.